about the resources operation. So first of all, we have the dam reservoir operation as one of the main water resources that we have in water engineering. As you may know, like the dam has been used for several purposes. Could be used for water supply, irrigation, and it's like the main purpose of the dam construction or the reservoir is for the provide water supply for irrigation. In most of the countries in the world, the water supply is used for irrigation. Maybe we can say like the 80% in the world average is used for irrigation. Apart from that, industry and domestic also are the largest users of the water supply. But as you know, the most important one in this kind of like the water supply system is the domestic water supply and requirements. And the water or household or residential water demand is the most and the highest priority. And if we have like the rota, for example, we have a lack of water resources, water shortage or deficiency, if we want to just go for like the rota, for example, and try to just reduce the amount of the supply to the users, the highest priority will be for the residential or water supply or urban or like for domestic use. The second priority is industrial, because industry is very important for the for living, actually, mainly for because sometimes the industrial activity cannot work at all without supplying water. So that's like sometimes critical. For example, some factories, specifically some specific factories, they need some sort of like the water source, and the amount of the water they need is huge. And surface water supply is one of the key elements for that. Dam reservoir is categorized as surface water. Apart from the surface water, we have the groundwater resources as well. So that is also very important. And last, which is the largest user, is the irrigation. As you know, irrigation, if the water is not supplied for irrigation, in some cases might just cause a lot of problem. The tolerance or resilience of the plant or for irrigation might be to some level. For example, if we don't supply water for like a few weeks, they can survive, but longer than that, it can cause a lot of problem. Specifically if there are irrigation based supply, if for example the agriculture is based on the irrigation, they cannot tolerate more than like the lack of water supply for like a few months. So that is something that you need to just consider. Okay, apart from this purpose water supply, another like the purposes, the water can be used for the flood control and mitigation. This is also very important for the water resources. And in many like the cities, or many like the for example rivers that's reaching or passing through the cities, flood control mitigation is one of the key purpose of the water dam reservoir. So that is also in some cases very important. Hydropower generation is another purpose of the dam reservoir. Specifically, just please pay attention to this point, that hydropower electricity is a big difference with the power plant or the thermal plant electricity. Does anyone know what the difference is, or what's the main advantage of the hydropower electricity rather than or compared to other sources of the electricity generation? Or have you heard of that? Because both of them, they generate electricity. Yes, this is something very important. It's clean energy, meaning that obviously that electricity generated without producing any source of like the pollution. For example, for the thermal plant, thermal power plant, if the electricity generation, it has to use oil, or it has to use like the raw oil, for example, or like any type of like the derivatives of the oil. and that causes like a pollution to the environment. And air pollution is like the key, like the problems of other like the source of the hydro or electricity generation. But that's like a good point. Is there any other points that you would like to mention about like a clean energy? There are like a very big difference between the hydropower electricity and specifically thermal power plants, or even like other sources, specifically, for example, nuclear electricity. Does anyone know or have heard of that? What is the let's say big advantage apart from like the hydropower electricity? We have some sort of like the wind, for example, electricity, you know, wind turbine, looks like for example hydropower turbine. And yeah, so what is that? Sustainable. Yes, yes, that's true. This is the, can you just explain a bit more about that, Khaled? What do you mean sustainable? You need to unmute if you like to just talk. Or do you have a mic to just explain what do you mean about sustainable? If you call it, can you just unmute and talk? Yes, go on. Your mic is on, but we cannot hear you. Colette, go on. Go on. No, we can't hear you. Your mic is on. I can see you have unmuted your mic, but we can't hear you. Anyway, don't worry. No worries, there might be a problem, but see how we can just fix it, because it's good to just have a like the more interactive discussion. I like you to just see what do you think about all of this. That's fine. So you can just mute your mic. This is okay. So anyway, so I can just try to explain some sort of like the sustainability. There are like some sort of like the key points, especially the sustainability is that what if you just look at the sustainable from environmental aspect, yes, that is true. It's like a more relevant to clean energy. But if you are just looking at the sustainability of the source, to be honest, it's a bit challenging, because it all depends on the inflow of the water. For example, if you have like, or if the catchment is experiencing drought, or if there's no water comes to the like, there's no inflow comes to the like the dam reservoir, and the heads in the reservoir, for example, depth of the water behind the dam is declined, for example, in that case, unfortunately, we don't have a proper hydropower electricity, or even like the hydropower plant cannot generate electricity properly. So that's like a problem. Anyway, so let me tell you the main advantage of the hydropower. Yes, Khaled, yes, you're talking.
Is it working now?
Yes, go on.
Oh, okay. Should I still answer the question, or?
Yeah, go on. About the sustainability of the hydropower electricity generation.
Yeah,
Do you have a point to make?
no, so I was going to answer the question. Sustainable, what it means with regards to the issue. So if anything, the most that I can say is that with regards to this being sustainable, and with along with wind turbines and whatever have you, um, basically they basically, as Kamal mentioned, they're clean energy, and they essentially don't run out. Um, in comparison to other things like um, I think nuclear, I don't think that's sustainable. Am I right? Is that not sustainable?
It needs to just see what angles you're looking at. If you say, even for the hydropower, if you say sustainable, I say, okay, what point of sustainable? If you look at, like, for example, from environmental aspect, because environmental aspect is one of the like the angles of the sustainability. If you look at this, no, obviously, yes, this is looks like, for example, clean energy. But if you look at the sustainability from the source of the energy, for example, it's not a problem. But if nuclear If you look at the, for example, sustainability, it might be a question because, you know, for example, we have a, for example, nuclear waste materials, for example, that cannot be recycled, for example, that cause an issue. But the challenge is not as easy as that one. For example, if someone says like that this is the clean energy, for example, hydropower, the situation is not as easy as that, that everybody can just understand and say 100% is like a clean energy. Because if you look at like a dam reservoir, we have a huge construction in an area. You know that. I wonder, I've seen, I'm sure you have seen some sort of like a construction site, especially in the UK. I told you before about like the HS2 project. Once they're just going to build, especially in the UK, that all the area are really green. If for HS2 project, if you've seen or come across, it's kind of like the project, it's like the only like the railway. Well, you might say, okay, just needs to just have like the maybe around like the 10 meters width. But if you look at some of the sites that they're just working on, especially in the UK, in London, for example, some area, that you can see they are trying to just remove all the like the surface vegetations, for example, or surface green area for something around like a few hundred meters in some places, for example. But it's not like they're working, for example, as a width of like a 10 meters all over the long or the distance of the like the system. So they have to just ruin and completely vanish all this kind of like the green area from one section. And the same for the dam construction. For the dam construction, is the situation is not as long as, it doesn't have like a very lengthy like the route, but it has a very large area, and that caused a big problem for the construction. And from sustainability, if you look at, for example, the lands that will be under the water when the dam is a new dam is constructed, you don't know how many, for example, area or how many historic area will go under the water, and a lot of like the rural area are completely vanished, and a lot of people have to relocate from their original house for that they may have been there for like 1,000 years. And unfortunately, all of this will happen because of the like the dam construction. As a result of that, dam construction at the 21st century, especially in the developed country, is really, really rare. I can say really, really rare. But in developing countries, in some of them, although there are like still some good sites to just build a dam, but there are a lot of hesitations for environmental concern that if they're just going to build a dam or not. So this is something very important to know. Moses mentioned about like the challenge of the hydro. A lot of energy is wasted because of the storage and transport issue. What do you mean by that, Moses?
Oh, I read somewhere that when it is produced, it's only like 60% of it is used. Otherwise, the rest of it is just dissipates because of when it's being transported from the source to the various places of consumption.
I'm not sure what this exactly means. I need to just get more information. But the fact is that, for example, once we just have, for example, let's look at this like the dam reservoir. Let's see, this is one like the hydropower. First of all, if the purpose of the dam is it's built only for hydropower generation, maybe that might be the, I don't know if this kind of like the points that you just mentioned is referred to this one. Is if the dam is purely for the purpose of the hydropower generation, is sometimes over the year, because of the heavy rainfall, for example, a dam is completely full, and for the safety, the dam reservoir operators have to release the water through other like the outlets. For example, let's say from the spillway, from the like the other outlets, apart from the hydropower outlets. You know, hydropower has got like the turbine that's got, no, this one has got the specific units and has a limited capacity or flow rate. So other than that, for example, if the flood is going to happen, huge amount of the water has to pass the way without going through the hydropower turbine. So that's we can say from the hydropower generation, that's a waste of the storage, because we couldn't use any of them at all in for operation. Look at here. Look at this example. This is the something very important is the zoning or zones of the behind the dam reservoir. You can see here there was some area dedicated completely for the flood control volume. For example, in a normal situation, in the best wet year situation, the dam operator cannot fill the dam more than this depth. Can you see? This depth is something that is for example, a red line. So if the water is just above this one, they have to release it from the outlets or the other for example, gates that they have. There is a spillway. You know, a spillway is for the could be for emergency or could be used for even for the transfer or discharge the water into the downstream. So, for example, you can see here, this is the reservoir discharge level, and also you can see here, this is the dead level. So we cannot discharge any water lower than, let's say in this here, lower than this level. You might just have some water storage here, but the storage capacity here, it needs to be here to be used for the sedimentation. Can you see? For sedimentation, just going to be used here. And one important thing is that we spend a lot of money, and a lot of effort to just build the dam. But one of the key and big problem of the dam construction is that the sediments we can block, obstruct the flow. Not only the flow, but also something that we never see is the sediment. Sediment, from the upstream of the catchment, especially environmentalists are very serious about this kind of a concern. They said naturally over the 1,000 years, for example, the sediment is washed away from upstream of the catchment, from the mountainous areas, and goes into the downstream. And sometimes, as you may have heard, sometimes the environmentalists raise this concern that flood, although it's a catastrophe and it's very bad for the human and for the people, but also it's very good for the land, because it can just bring all the sediments and spread it all over the land in a big area, and that sediments which is spread all over the land can be used and can make the land fertilized. So fertilization can happen. But because of the dam block all this kind of flow of the sediment going through the downstream. And this is not only fertilization, but also it can just change the regime of the flow or sedimentation throughout the river as well. The main problem, as I can explain here, is that the sediment is accumulated behind the dam, and it causes some sort of scouring. Scour can happen downstream of the dam. For example, because the the scour is going to happen regularly, and if you're just going to obstacle here, the sediment cannot just fill all these kind of the gaps which is created downstream of the reservoir. So as a result of that, this kind of sediment is accumulated here, and after a while, interestingly, let's say could be as short as 20-30 years, but it could, but maximum of 100 years. As you may have heard, the lifetime of the dam is defined. For example, these dams are really seems to be nice, but some of them they might just be completely out of use after 100 years, because it's completely full of the sediment behind the dam. And in that cases, they cannot be used for the definitely water supply, because there's no capacity. All of them behind the dam is full of the sediment. And interestingly, once you're just going to design the outlet cannot be located in a lower level. Why? Because after a while, the sediment, depending on the years, there are some the formula and some methodology to calculate how many years does it take to just fill the behind the dam with the full of the sediments. But based on whatever you have, you need to just design the outlet in different levels. because the lower levels will might be blocked earlier. Maybe at least it could be like the blocked in like the 20 years or something if you're just going to design it properly. But something very important is that you need to just make sure that you have like a good sediment management in the dam. So in any occasion, if there's any opportunity, you need to just release the sediment and make sure that the dam becomes like the empty, the reservoir. Anyway, the fourth purpose is like the recreational. Recreational is another like a purpose because, you know, you may know it's not like a big purpose, you know. Recreational, I'm just saying that is normally just used for boating, shipping, and, you know, this kind of like the activity that they're just going to use. But as I can say, this is like a completely subsidiary like the purpose. The primary purpose is definitely has to be one of these three, at least one of these three. And some reservoirs has got more than one purpose in the first three. They might just use for the water supply and flood control, or use for water supply and the hydropower, or even use all of them together. All three: hydropower, electricity, flood control, and water supply. So that might happen as well. So those dams that are used for all these kind of like the purposes is called multi-purpose operation. Okay, or multi-purpose operation is like the popular name for this kind of like the dams. Anyway, so there are like some very nice movies. Specifically, they are from like the Australia. Please just have a look. Make sure you're just gonna look at them very carefully. Especially tidal power. Tidal power just shows that how it just goes, but unfortunately, because of the online, we can't show them here. For undergraduate level, we have like the module environmental protection engineering. We show these videos very well, but please just have a look at them. The link is here, tidal power, and it just compare the comparison of tidal power with, for example, hydropower. Tidal power is another source of the energy. For example, it works based on the tide. Once the water level rise and decline, it can just generate electricity, and something very interesting that we can just use in here. What we just very interested to look in here is the dam demand for reservoir storage capacity. Please pay attention to this point here. So what we're just looking here, we're just trying to just analyze how we can just work in this kind of like the circumstances, how we can just determine the storage capacity of a reservoir. This is one of the important points of the water engineers. Once, for example, you find like a good site has been located, or you want to just see what is the like the storage you need for your purpose, and depending on the like the inflow that you have for your in the system. So as you know, the reservoir is just a structure for store the water. For storing the water, you need to, because why? Because we have the uneven distribution of the inflow. In sometimes, for example, in the winter we have a high flow, in the summer we have the low flow. However, on the other side, we have a high demand, and the result of that is like the we have the during the spring we have the high value of the like the flow and snow melt seasons as well. On the other side, we have the demand which is very high during the summer, and also during the winter the demand is really low. Specifically for domestic demand is more or less similar. Industrial is more or less similar. However, as I remember I told you, more than 80%, around 80% of the demand is used for the agriculture, so which is really high in the summer. And in the winter, you know, normally for planting and for irrigation, normally it's not, you don't irrigate. Even for semi-arid region, you don't irrigate them over the winter. If there is a little bit like the rainfall, that is enough. And also the other reason is that there is like a little bit like the rainfall, and you know, for example, because there is no like the leaves and obviously aspiration or like the evapotranspiration is not used by the trees, and normally the plant and trees goes to the hibernations over the winter, so they don't need a lot of the water from the roots. But if there is any kind of the requirement, it can be supplied from the minimum rainfall. And you know, the evaporation is also very minimum over the winter. Obviously the irrigation is really minimum over the winter period. However, on the other side, through the summers, we just have a lot of the demands of the irrigation. So as a result of that, we need to just regulate the stream flow. The regulation of the stream flow can be done through the building and construction reservoir. So we need to just make sure that we regulate it and block the water through the high flow rate during the winter and spring, so that we can use them for the summer period. So and this regulation is possible by constructing reservoir in the stream. Okay, is there any question? No? Okay, so let's look at the features in more details. You can see here one of the key points here, the variations of the flow rate. If you look at here, this is the variation of the flow rate in the top figure on the right. The red dashed line is the inflow curves to the for example, the site, let's say to the reservoir, and imagine that the outflow is fixed. Okay, so we are going to use the same or fixed amount of the outflow, or you have a fixed amount of water demand, let's say. But you know, the water demand or water supply can be used uneven or the variable as well. But you know, the nature of the inflow is completely variable because it's based on the nature of the water inflow to the reservoir. So the dashed line has got a curve, has got a minimum and maximum. But if you have for example, a constant outflow over the year, so let's say this cycle is just going to happen every year, is exactly the same as that one. You can see here over the, let's say, in the inflow in the, let's say, in the summer is the small, and in the summer the use or the water demand is high. So all the time, if you have a reservoir, this is in this period you are releasing the water from your dam reservoir. However, during the winter period or the spring, or once we have a high inflow, you have a lot of the storage here, and that is the water is stored behind the dam, and it happens again and again over the let's say the next period of the high water demand. The dam is releasing. So this cycle is going to happen every year. But just bear in mind, the dam is not going to be designed only for 1 year purpose. In some cases, or many cases, you have to just have the dam reservoir to store the water not only for 1 year, because you know, as you know better, in some years we might have experienced the drought, and you might just experience drought for a few years. So you cannot say, okay, let's say by the end of the summer, for example, I just empty the dam. You cannot just do this, because maybe the following winter you may not have a lot of rainfall, and as a result of that, if there is a very hot summer the following year, you might experience a lack of water supply. So if the proper planning for water supply or the dam operation is that to make sure for the area that you are planning, to make sure it can just store the water for not only for 1 year, it can just stay for at least few years. So it's very important to make sure that you don't use it for the only 1 year cycle. So this is also another the points of especially the big dam reservoirs is just constructed to store the water for not only for 1 year, could be for few years. And the same for the flood as well. You know, for example, you can't say, for example, at the end of the summer, oh, there's no flood is coming, and let's just completely use the whole capacity. And you need to just make sure, for example, with whatever the level or volume you have, there might be another flood comes to the reservoir, and you have to just provide some capacity for that all the time. So because in some cases some people might say, okay, let's just use the whole capacity because there's no like the flood comes to the reservoir because we have all the finish or that sort of this. So this is for the dam reservoir. So stabilize varying seasonal supply over a year or more. The other like the figure that you can see at the bottom right is the variation of another type of the like the reservoir, but that is called a service reservoir or tank. The service reservoir or balanced reservoir is used inside the water distribution system. You know, remember we discussed a lot about like the water supply system inside the city, but the cycle of the dam service reservoir inside the city is completely different from the seasonal reservoir that we have outside the city in the catchment area to collect the annual water supply. The one for the service reservoir or tank can collect the water for a cycle of the 24 hours. That's it, for a very short time and period. It has to just collect the water during the different demands and supply. And look at here, interestingly, the inflow and outflow is completely vice versa compared to the seasonal reservoir. You can see the demand curve, the outflow or demand curve, yes, is like the solid blue. You can see the demands like the fluctuated because the demands of the customers, remember we discussed about that before, that the customers might just use different amount of like the water based on their need or demand. However, the inflow that you pump into the reservoir or the service reservoir is going to be fixed, or you can fix it, or in some cases it might be different as well. But if, let's say we just pump it with the same rate, with the constant rate, and the dash red line is just going to be fixed. So it's inflow and outflow completely different from the previous one. And also the cycle is also 24 hours. So just pay attention to this point as well. And you can see this kind of like the dam is going to stabilize the pressure. You know, remember we discussed about this, and we'll also experience or we practice this kind of like the what does this kind of like the balancing means of the service reservoir, because we need to just balance this water supply. So this is very important to just make sure that we have a like the proper balance. In some times that over the day that the demand is low and the supply is higher, it means that we're filling the service reservoir tank. In sometimes that the demand is high and the inflow is like the low, we are releasing like the water. So this is a very important point to just see here. Okay. So that's the difference between the seasonal reservoir and balancing reservoir, which is used in different cases. Okay. Let's just move on to another like the next slide. Is there any question? Especially for the previous one here. No question. Okay, let's move on. Okay, so we're just getting close to the level that how we can just determine the storage capacity of a reservoir. So before going to that one, let's just analyze some of the other key points here. The variations between demand and supply. Demand is denoted by D and supply is denoted by S. So it's very, very important, the variation and comparison of the demand and supply. And that's a key point, that if you're just gonna go and responsible for any kind of like the things like that, the first point that you need to see and understand and try to figure out is that what is the total demand and what is the total supply of water. So you need to just have a like the comparison between these two to make sure that do you need any kind of like the storage or not. So the point here is that if they're like the red line is like the supply, and sorry, if the blue one is like the supply and the red one is like the demand, if you have such a like a curve like this one, for example, first of all, if the like this total supply of the water okay, total supply of the like the blue one is sufficient to meet the total demand during a sufficient period of time. Okay, so if this is like, for example, if the total S is greater than the total D, okay, you need to just store the water. Okay, you need to store the water once the S or the supply is less than D, or the supply is less than the demand. For example, if you're just gonna see this kind of like a fluctuation for S, and this is fluctuation for demand. So in this period, the supply is larger than demand. Obviously, if that's the only thing, you can say, okay, there's no need for the supply. However, in this period, the demand is higher than supply. So definitely for this period, you need to just have like the storage. So for that reason, if your variation of the supply and demand is just changing like this one, the top, like the red and blue ones, you definitely need to just have like the storage reservoir. However, if the supply is the blue one and the demand is the red one, the lower red ones, all the time throughout the year, the supply is greater than the demand. So obviously there's no need to just have like any reservoir. So that's like a very simple as that. So unfortunately, sometimes there are some misunderstanding for engineers that they might say, oh, in all cases we have to just build like the reservoir. No, if the supply all the time throughout the year is larger than the demand, you don't need to just go for a reservoir like this one, the lower one. You need to just do this one whenever, if you have some period over the year that the supply is is lower than the, or smaller than the demand, and the demand needs to be supplied from some sources. Okay, so that's like a very important point. Okay, so let's see what is like the methodology that we're just going to use for determination of the reservoir storage capacity. So we have like a few methods here. We're just going to go through with I'm just going to introduce all of them here, but later on we're just going to go through with some specific of them. The first method is mass curve analysis. Mass curve analysis, we got like the two the approaches for that. We definitely cover mass curve analysis here. We can either determine the reservoir capacity for a known yield. Yield is the amount of the water that is used for a specific purpose. Okay, or we can determine yield, or the amount of the water that we can extract or take from the reservoir with a known capacity. So you need to either know the reservoir capacity, or you need to just know the yield. So either of them needs to be provided or needs to be assumed, and the other one can be determined. So this is something different. It's called like the nature of the mass curve analysis. The other method, or the second method, is like a very similar to the mass curve, but the way that we present it is like the different. It's called a sequent peak analysis. Okay, so we're just gonna explain this one. This is like a more or less straightforward. The third method, I mean, the first two is like there are some sorts of techniques. If you have like a cycle of the water supply and demand, you can easily determine the storage reservoir. However, if the purpose is to just calculate the sequent peak analysis, if you're supposed to just calculate like a few years analysis, for example, you want to include like the drought years and wet years into consideration, specifically for the water supply, you need to just take into account the operational approach, or some sort of the techniques to just look at the operational techniques for that. There are some the methods for to calculate the dam reservoir based on the operational analysis. Some of them, one of them is called the system dynamic approach. Systemic dynamic approach is the one typical and popular the methods to just calculate the dam reservoir, and the other one is used for example, optimization technique. Optimization technique to just calculate the maximum or the optimal the reservoir operation in order to make sure that we can have a water supply throughout the year for the specific year, with considering uncertainty of the inflow and also the other levels of uncertainty. For example, uncertainties of the demands as well, and other source of uncertainties. How we can just operate the reservoir. And that operational study or operational study is not only for the purpose of the capacity, it's also for the purpose of the operation, how we can allocate the water to the users all over the years. For example, if you have, a reservoir, maybe you don't want to just give them the fixed yield. You need to just give them per year based on the demand is going to just predicted or forecasted in the future. You want to just allocate some specific level of the water. So in that case, the supply is not fixed. So it depends on for example, the weather forecasting or the forecasting of the water supply available in your storage. So this is also something that all of them is considered in operational study. So we don't go with that one, that sort of operational study, but this is something that you need to know what sort of this, if you want to just do some sort of a little bit sophisticated analysis, you are able to just do this analysis as well. So specifically for the large dam reservoirs, operational study, and in some cases that the variation of the inflow to the reservoir is huge, you may need to just look at the operational study carefully as well. So anyway, there are some other approaches, might be minor, to determine the capacity of the reservoir storage. So that's can also proposed by some other researchers. Okay, let's look at how we can just go ahead with this kind of the storage capacity. So first of all, we have the very, very basic formula. The difference between the inflow and outflow is equal to the variation of the change in the storage. You know that. Inflow minus outflow, the top formula, is the plus minus change in the storage. So we have this one, and we can say here S, the capacity or the cumulative net storage. Let's say cumulative net storage could be like a plus and minus, is equal to the maximum of the sum of the input minus sum of the output. And this formula can be written, sigma can be taken out of this and can be written as the sum of the input minus output. If you just have the input inflow, let's say input and output is inflow and outflow. Inflow and outflow for each month, if you have that one, if you plot the variations of that, you can see, or the sum of all of these kind of the variation can give you the cumulative net storage. So this is something that you can just calculate. And what is the input and inflow and outflow? Is that the volume of the outflow times the delta T. Delta is over some specific time. In operational study, normally specifically for the larger scale, over the year, with delta T is considered as a 1 month, okay, or the 30 days, let's say. So obviously the multiplications or the product of the outflow, which is normally presented, is the average of the cubic meters per second times the delta T. The final the OT or IT, which is the outflow or inflow, is written as the L as a the volume, or it could be the sorry, not L. L is L is liter here, but it could be written as the cubic meters or liters. So in some cases might be liters or cubic meters. So this sort of the way as a basic we're just gonna use, as you know, this formula. Let's just look at the sequent peak method, how it's just gonna work. If you have the fluctuations of the flow minus demand, or the inflow minus the outflow, you can have this one, and you can see this kind of the variations like this one. And let's say, for example, here, if you have a reservoir is emptying, sorry, it's hang on, if there is a flow here at the top and minus demand, if we have the if you have the negative value, means that the demand is higher than the flow. So in this case, the reservoir is emptying, but in this period, the reservoir is filling. Okay, filling the reservoir. We're just gonna get to like the first peak, and then we're just gonna going down to the like the this is let's say this is for analysis for a few years, let's say, or could be for 1 year, but in this case could be for like a few years. And here this is the period, this is the emptying. Okay, so if the dam reservoir is full here, so until this point it can get completely empty, and from this point just start like the filling the reservoir. Can you see? So if you're just going to get to this level, if you analyze from the beginning to here, so obviously the storage required is that it needs to just have like a full from here to empty from here. This is the storage you need. But here again is filling, and becomes full in here, and again until this point it just becomes empty. There's another like the peak here. Okay, so this is like the sequent peak. So it's like the sequent peak here, and so the maximum so this kind of like the highest changes that we expect, we just consider the like the storage capacity. For this like the one change, and this another like a change or storage. So the maximum change for this one, as you can see, is higher than this one. So this one compared to this one is higher than that. So we can consider the highest difference between the maximum and the minimum one, so we can consider as a like the storage capacity. So this is for this kind of like the variations, we can say we need to just have this kind of like the storage capacity. So this is like the one way to calculate the storage capacity. This is called like the sequent peak method. Normally you can just look at the like the variation, or look at like the data in an Excel base, and you can just make a comment on that. So let's look at another like the method that specifically we're just going to use this in our reference book as well. So we have one example for this. Let's see how it works in this example. Okay. In this example, we have another example. Sorry, this is like the called like the mass curve analysis. Is this like the method also called like the ripple diagram method, presented in 1883. This is like the very like the most widely used like the method in this kind of like the approach. So let's just look at here. If we look at this kind of like the graph, what we're just gonna do is that here we have assumptions here, but this assumption is not always in place. In some cases you want to just have like some other assumptions. In this example, demand is constant. Okay, the demand is constant. But once you're just gonna plot this one in a plot over the time, can you see this is the time? Over the time, you just draw the accumulations of the supply and demand. So accumulation is like the delta S and delta D. So, okay, total inflow and total outflow. Because we said the demand is constant, the accumulated value per month is this kind of like the line. Can you see this line? This line is like the demand. Can you see this? The demand is like the fixed, like the linear one. However, the supply has got a like the different, because supply, because of the nature of the water to the reservoir, is like the difference. So we can have like this kind of like the variations. And the volume in this kind of like the technique, can you see here? The highest, the difference of the one that we just analyzed in the figure below, the difference between points C and D. But to be honest, this is like once you're just going to take the differentiates of this curve, once you take the differentiate, it just becomes horizontal, this kind of like a curve. And you can see that sort of like the difference between those points. And in the like the graph, you can just take and calculate this kind of like the volume. So that might be a little bit difficult to just calculate this kind of like a curve on the tangent from here, tangent from this one, tangent from the like the maximum minimum, to calculate the volume. But anyway, so I mean, this is not the storage capacity. This is a volume they want to just see between point C and D. But we need to just take the tangent, just calculate here. So this is the method that the mass curve analysis can use. But how we can just use this one, maybe in this figure, it might be better. You can see in here, in this figure, you can see the difference between the storage and the demand. You know, here is like the supply, but this is not accumulated. Accumulated was the one below. Okay, this is the absolute the supply and demand. You can see here times at the times A, for example. Sorry, not A. So at this period, supply is higher than the demand. But you can see here the dam is filling in this period. But in this period between T1 and T2, the dam is emptying. So whatever is collected during the first period until here, it's just gonna be empty in this period. Okay, and then later, after that period, again, this is going to be emptying as well because the demand is higher than that, but is emptying here. But later on is filling like that as with this kind of like the size B. Okay, you can say here very simply, if you have like a dam reservoir here, your dam needs to just have a capacity of the A plus B. I think this is very clear that you can just get this point. That's if you have a reservoir with a capacity of the A plus B, that reservoir can fulfill this kind of the demand. But if you look at accumulative value here, the variation of the supply is a curve plot or diagram, and the linear one is the mass demand. Okay, so that's the difference between mass demand and mass supply. So and here you can see the tangent of this point of this curve and the tangent at this point. So the tangent of these points, if you have there are two parallel lines. For example, the tangent, if you're just going to get the tangents in this kind of the curve, the vertical distance of these two kind of lines is equal to A plus B, you know, because it's the B here, because it's the A here, and this is the vertical the distance. So A, B, and obviously this one is A plus B. So there's a vertical distance of this to the farthest point of this curve to this kind of the line. So you need to just have that one. This is the B and this is the A, and so this is the so anyway, so this kind of the curves are called the mass, either demand or mass supply. So you're just going to use here in this example.